Hello and welcome to Engineering Economy. This is Dr. Ala Kamerdiner. Today we will talk about depreciation. Specifically, we will discuss basic aspects of depreciation. We will talk about historical depreciation methods. We also will learn Modified Accelerated Cost Recovery System or MACRS method for calculating depreciation. And we also will talk about depreciation and asset disposal and discuss unit of production depreciation. We will talk about depletion, and last but not least discuss the use of spreadsheets in computing depreciation. So the learning objectives for today are for us to be able to understand the concepts of depreciation, deterioration, and obsolescence, use historical and MACRS methods to calculate annual depreciation charge and book value over assets' life. We will also be able to account for capital gains or losses, ordinary losses, and depreciation recapture due to disposal of depreciated asset. And we will be able to use unit of production and depletion depreciation methods in economic analysis. And then last but not least, we will be discussing how to use spreadsheets to calculate depreciation. So let's talk about this interesting story. Is baseball going broke? In 2001, Major League Baseball, MLB, had over $3.5 billion revenues. However, the commissioner asserted that baseball had suffered a loss of over $2 million for the year. Well, owners of baseball teams deduct stadium depreciation as much as $5 million. How would this affect their calculations? IRS considers bearer bonds a wasting asset and allows the owner to depreciate a large portion of his contract. Why? Decline in the market value of an asset due to deterioration or obsolescence is known as depreciation. There could also be decline in the value of an asset to its owner. And the systematic allocation of assets cost over its useful or depreciable life, which is basically an accountant's definition of depreciation. Let's talk about depreciation and expenses. Expenses are part of regular business operation. They're consumed over a short period of time, and sometimes they're recurring. They do not lose value gradually over time. They're subtracted from business revenues as they occur, and they reduce income taxes as they can be written off when they occur. Examples of expenses or costs are labor costs, utilities costs, materials costs, insurance, and so on. So expenses are not a depreciation. On the other hand, depreciation are the business costs due to capital assets are not fully written off when they occur. Right? Those are the business costs. And the capital assets lose value gradually over time. When you're using an equipment, it becomes less. Maybe it becomes more outdated, or with the use, it becomes less effective. And capital costs must be written off or depreciated over its depreciable life or recovery period. Reduce the taxable income and thus reduce income taxes as they were written off. And it's a non-cash cost. Examples of depreciation are depreciation of building. As building becomes older, they might be losing some of its value. Plants, so as a plant is getting older, the same, some of the equipment becomes less effective or maybe even obsolete. Machines. So what are the basic requirements for depreciation? Property is considered depreciable if the property is used for business purposes to produce income. So it's very important requirement. Also, the property must have a useful life that can be determined, and the useful life must be longer than 1 year. So we cannot have undetermined or indefinite useful life, and the useful life must be more than a year. The property must be an asset that decays, gets used up, wears out, becomes obsolete, or loses value to the owner from natural causes. Only the owner of the property may claim depreciation expenses. What are the types of the property? There are tangible property, and that's the property that can be seen, touched, and felt. Examples of tangible property are real property. That includes land, buildings, and things grown on, built upon, constructed on, or attached to the land. Personal property is another type of tangible property, and that includes equipment, furnishings, vehicles, office machinery, and anything that's tangible, excluding real property. There is also intangible property, and that's a property that has value but cannot be directly seen or touched. Examples include patents, copyrights, trademarks, trade names, and franchises. Almost all tangible property can be depreciated, except land, factory inventory, containers considered as inventory, and leased property. Again, as you remember, only owners can claim depreciation. So if you're leasing, you're not an owner. Tangible property used in both business and personal activities can be depreciated, but only in proportion to the use for business purposes. Intangible property can generally be depreciated. So let's talk about calculating depreciation. So in order to start talking about it, we need to define the book value of the asset. So the the property item is known as asset, and it has a book value at each time. And the book value starts with a cost basis, which is initial cost of the acquiring this asset, and then each time period we subtracting or reducing this value by depreciation amount. So the book value of the asset at time t is the cost basis minus the sum of all depreciation amount through the years from 1 to t. Again, BVT denotes the book value at the end of time t, and cost basis, also denoted by B, is the dollar amount being depreciated, including the asset's purchase price and any other cost necessary to make the asset ready to use. And capital DJ is a depreciation deduction in year J. Notice it's different from the small. So now if we have a sum of DJs, that's accumulated depreciation charges from time 1 to time J. So in this case, we could actually replace this with a capital D. Let's take a look at the change in the book value through time. So this vertical axis will denote the book value, and we'll have horizontal axis that denotes the time, and this will give us depreciable life. So the start of the life, we're gonna start with B, which is a cost basis. So B is a cost basis. This is the dollar amount that's being depreciated, and this is a salvage value, right? This is a salvage value. This is how much at the end of depreciable life, how much we're gonna get for the asset. And this is the total depreciation charges. Basically the difference between the book value and the salvage value. And this line shows the reduction in the book value during the depreciable life of the asset. And this curve depend on depreciation method that is used. So what are the depreciation methods? Well, the pre-1981 historical methods include straight line or SL depreciation method, sum of the year's digits or SOYD method, declining balance or DB method, and required estimates of useful life and salvage value. So between 81 and 86, the methods that were used were Accelerated Cost Recovery System or ACRS, and what that method changed from the previous methods is that now the property class lives were defined. So different types of properties, they were given specific number of years as their useful lives, and the salvage value was ignored or assumed to be zero, and then also the shorter recovery periods were used. Then starting with 1986, which is over 30 years ago, modified accelerated cost recovery system was introduced. So the previous ACRS method was further modified, where the number of property classes were expanded, and also in that system, half-year conventions were introduced for the first and the final years, to account that the asset is usually purchased somewhere in the middle of the year, or could be even potentially at the end of the year, could still be at the very beginning of the year, but this half-year convention was introduced in the modified accelerated cost recovery system. So let's start first talking about historical depreciation methods. The straight line method is very simple. To find the depreciation amount in period T, you simply subtract the salvage value S from the cost basis B, or initial cost of the asset, and then you divide it by the number of years N. That's the useful life of the asset. The sum of the year digits, this method is a little more complicated, and here's the DT amount, the depreciation amount in period T, is computed as N minus T plus 1, where N is useful life of the asset, T is the current depreciation period, so minus T plus 1, multiplied by the difference between B and S, basis and salvage value, and then divided by the sum of the year's digits. Double declining balance, or DDB method, is basically a method where the depreciation amount is determined as 2 divided by number of years N of useful life, and then multiplied by the book value in the previous during the previous period. So then here again, right, as I described, we have the different notations where B and S are the basis or the cost of the assets made ready to use, and the salvage value at the end of the depreciable life, respectively, and as a number of years in depreciable life, and the small dt is a depreciation charge in year T. And then to get the sum of years digits, you just basically use this formula where n multiplied by n plus 1 divided by 2. So let's take a look at the single life depreciation method. And this is example where the cost of the assets, or B, is 900, depreciable life in years is 5, and the salvage value at the end of 5 years is 70. So then we can find the single line depreciation is simply B minus S divided by N. Each time it's the same, so it's a linear straight line. So then the dt is 900 minus 70, which is 8 130 divided by 5, and that's 166. So you see that each year, at the end of year 1, we have 166 as depreciation amount, and again at year 2, 3, 4, and so on, all the way through 5 years, we have depreciation amounts being the same. And then the sum of those is determined as basically sum of everything before, so this is just 166. Then by year 2, it's sum of everything before year 2, so it's 166 plus 166, so this is 332. By the end of year 3, the sum of DTs is 166 plus 166 plus 166, that's 498. And then the book value is similarly determined, right? We start with at year 0 with the basis, so the book value is equal to the basis, and then we start subtracting the amounts from the basis, right? So the sum is subtracted from the basis. So from 900 we subtract 166, get this much. From 900 we subtract 332, get this much, and so on, all the way to the end. And at the end, you see it all depreciates right to where the book value at year 5 is 70, which is exactly the salvage value. And if we plotted these values of book values over time, like this, we're gonna get a straight line, right? Because it just decreases by the same amount. Alright, let's take a look at this, alright, and again, it decreases all the way to the salvage value starting with the book value. Let's take a look now at sum of years digits depreciation. So keep in mind that the sum of year digits is found from the formula where n is multiplied by n plus 1 and then divided by 2. So then, right, what we do is exactly this, right? Again, book value minus the salvage value, and then we use the sum of years digits. And just to remind you the formula again in case you forgot, right? We have n minus t plus 1 and then divided by n multiplied by n plus 1 over 2. So the 2 would be here, and then we have n multiplied by n plus 1. But basically this would depend on the year t and would be reducing as this amount would be reduced as the t becomes larger. So that's exactly what we see there in example 11.3. The values are being reduced, right? It starts where we have 90 minus 70 or 830, and that's multiplied by, right, for year t year 1 we have n, which is 5, minus 1 plus 1, so it's still 5, and then divided by the sum of year digits, that would be 5 multiplied by 6 divided by 2, or 15. So 5 over 15, this is a third of 830. So that's what we get. Again, summing those up, then it decreases, right, because on top there, before we had 5, now we're going to have 4, because we have 5 minus 2 and then plus 1, so it will be 5 minus 1, 4, here divided by 15 and multiplied by 830, which is difference of 970. So this is how this is computed, and so on, all the way here, adding those up, and then to get the book value, we subtracting, right, from 900 we subtract this to get this, from 900 we subtract this to get this book value, and then from 900 we subtract this to get the end of the third year book value, and then from 900 we subtract all the, like, the sum of all depreciation by the end of year 4, and that gives us the book value at the end of year 4. And finally, right, this 830 is the sum of all those depreciations that we had. So 830 is subtracted from 900 and we get 70. And so if we were to plot it, notice, right, the linear was like this, right? This is actually below the straight line. This sum of year digits is below the straight line. And so at first, right, we have a higher amount. We have almost 277 at first. So sooner we depreciate the asset faster. And that offers an advantage in terms of the in terms of using, like, if you were to use this for taxation purposes. And again, we depreciate all the way to the salvage value. So again, another method is double declining balance depreciation. And here, as you remember, that was computed by the formula, where again we have 2 over n. Just to recall, this is double declining balance. The depreciation amounts are 2 over n, and then multiplied by BV, book value, in the previous year. So when we start, right, in the first year, the first depreciation amount, the book value from the previous is BV0, or the basis. So it first starts with 2 over n over basis, but then because the basis declines, then this continues. This is a constant, but the book value declines. So it becomes, each time this depreciation amount becomes smaller and smaller. Alright, so let's use this formula in our example. So here you see we have the book value in the year 0 is 900. So 2 over n is 2 divided by 5, because n is 5. And so we have 2 over 5 multiplied by 900. So that would be a 360, and then we would have the summation of all the previous depreciation amounts are still 360. So we subtract that from 900, and then it gives us 540. And so to find this amount, the D2, we use B1, and we multiply it by 2 over 5. And so when we multiply this by 2 over 5, dividing this by 5 is going to be 108, and then multiplied by 2 would be 216, and that's what we see here. And then to get this value, it's a sum of previous ones all the way up to 2, so we're summing these two. So 360 plus 216 is exactly 576, and then this 576 is subtracted from 900 to get 324. And so then to find this next one, D3, we use the BV2. This is BV2. So this 324 is multiplied by 2 over 5, right? 2 over n, 2 over 5. And so again, what we get is now 129.6. Then summing all these will get us this. And when we subtract this from the 900, which is our basis, we get this much, and so on all the way at the end. And see here, it's almost approximately 70. It's not exactly 70, but approximately 70. So we get 69.98. If we were to plot this, we'll get the values where, notice it's even sharper than the previous sum of the year digits. It's even sharper decline in the first years. So again, this method gives us even more advantage because we take depreciation earlier. So 360 is more than what we had before, where it was 277 in the first year. and so on, right? So we have these larger amounts earlier, all the way, and the end was the approximately salvage value. So what are the advantages of modified accelerated cost recovery system, the system that was introduced in 1986? Well, first of all, the property class lives are less than the actual useful lives of the assets. The definition of MACRS classes of depreciable property is based on the guidelines of the Asset Depreciable Range, or ADR. With ADR, each class of property has a lower limit, a midpoint, and an upper limit of useful life. The ADR midpoint lives were somewhat shorter than the actual average useful lives, and the MACRS property class lives are shorter than the ADR midpoint lives. The salvage value is also assumed to be zero, so you can depreciate more. And so at the beginning, right, you can depreciate even more because the salvage values are assumed to be zero. And the tables of annual percentages simplify computations. So there is also general depreciation system known as GDS, and it's based on declining balance with switch to the straight line depreciation. And there is alternative depreciation system, or ADS. And ADS provides a longer recovery period and uses straight line depreciation. ADS must be used for tangible property used primarily outside the United States, property that is tax exempt or financed by tax exempt bonds, and farm and property placed in service when uniform capitalization rules are not applied. ADS must be elected for an asset, and it's not possible to switch back to the general depreciation system, or GDS. So let's talk about procedures in applying MACRS-GDS depreciation. First, we need to determine if property is eligible for depreciation. Then we need to determine asset's cost basis, B, cost to obtain and place an asset in service fit for use. And for real properties, the basis may include certain fees and charges such as legal and recording fees, abstract fees, survey charges, transfer taxes, title insurance, and so on. The third step is to determine the property class and recovery period. We use property class given in the problem, and we match asset name with MACRS GDS property classes, and those property classes are given in table 11.2, and then we use IRS publications such as table 11.1, and then use ADR class life to determine property class. So let's take a look at how we can apply MACRS-GDS depreciation. To find the depreciation amount, we simply multiply the basis by the rate for the specific period. So again, the DT is the depreciation charge near T, capital B is the cost basis, and RT is appropriate MACRS percentage rate. So here's the table 11.1, and it gives you an example of class lives and MACRS property classes. So here you can see, for example, asset description, and there's also an asset class. So office furniture, fixtures, and equipment is asset class 00.11, and more importantly, this class has 10 years life under the ADR. And if you use the MACRS property class, you notice that it's actually smaller. The GDS gives you a smaller class life, so that's more advantageous. And the GDS gives you class life of 7, so we would use 7 years using MACRS-GDS. If we were to use an alternative depreciation system, ADS, rather than the general depreciation system, GDS, then the class would be 10 years. For information system, which includes computer and peripherals, you can see the GDS depreciable life is 5. under modified accelerated cost recovery system. And so on. You can see different examples of different assets. So here's additional descriptions and also the class lives. And here's a table 11 too, and that gives you MACRS-GDS property classes, and that includes 3-year property. 3-year property, it includes special handling devices for food and beverage manufacturing, special tools for manufacture of finished plastic products, fabricated metal products, and motor vehicles. Property with ADR class life of 4 years and less. For 5-year properties, that includes cars and trucks, and the depreciation for cars is limited to $2,960 in the first tax year, and then $4,700 in the second year, and so on. Aircraft, equipment used in research and experimentation, computers, petroleum drilling equipment, and property with ADR class life of more than 4 years and less than 10 years. And the 7-year property is all other property not assigned to another class, and includes office furniture, fixtures, and equipment, and property with ADR class life of 10 years and more, but less than 16 years. So continuing, there is also 10-year property, 15-year property, and 20-year property. There is additional 2 properties that are not personal. This is the real property, real estate. And so the real estate property has 2 basic classes, 27.5 years, and that's for residential rental property, which does not include hotels and motels. And then 39 years is a non-residential real property. So here's another table, table 11.3, and this is very useful table. This is a table from which you determine the percentage rates when using MACRS general depreciation system. So here you have a 3-year class. If your asset falls into 3-year class, then it means 3 years. However, you can see that the rates are given for 4 years. The reason the rates are given for 4 years for this 3 years class is because we have this assumption under MACRS. We have the assumption of half year during the first year and half year during the last year. So this half year at the beginning is moved to the half year at the end there. So you can see it would have been 66.66 if it wasn't for a half year assumption. Because of the half year, you actually use 33.33%. And so you can see that for not just for a 3-year class, but for other year classes, it's always the year plus 1. This is a number of years that is depreciated through because of this first and the last half year assumptions. So for 5 years we have 6 year percentage rates, and for 7 years we have percentage rates for 8 years, and for 10 we have 11, for 15 we have 16, and for 20 a year class we have 21 years for which we have the percentage rates. So then you can see that these stars, right? What do these stars mean? The stars means is when we switch from the double declining balance to the straight line depreciation, and that's when it offers a faster depreciation. So at first it's we using the double declining balance, and this is the year in which we change to the straight line, because the straight line offers a faster depreciation than double declining balance. And the same here, right? This year 4 in 5-year class, that's a year when we switch to the straight line from the double declining balance, and so on. All those stars gives us the years, and you can see right after this is pretty much the same. So it's a straight line from here, straight line from here, and the only difference why we have, say, 0.90 here for 15, and then 0.91, and again 0.90, 0.91 is because of the approximation. Alright, so let's take a look at calculation of MACRS-GDS percentages to understand how those rates are determined. So the 3, 5, 7, and 10-year classes use double declining balance to 100%, and the 15 and 20-year classes use 115% declining balance depreciation. All classes convert to straight line depreciation in the optimal year, and that year is shown with asterisks. And a half year of depreciation is allowed in the first and the last recovery years. Salvage values are assumed to be 0 for all assets. So here's another table, table 11.4, and that gives us MACRS-GDS percentage rates for the residential rental property. So remember, that's a 28.5 year. So that's what you see here. We actually, rather than half year assumption, we look at the months placed in the service. So it depends on the months placed in the service. So for the first year, we're looking at what months it was placed in the service, and then for the these are the rates for each month. And then for non-residential real properties, it has a life of 39, depreciable life of 39 years. This is the rates, the percentage rates, and these include monthly rates. So here's example 11.5, and it shows us how to calculate the MACRS-GDS percentages. So let's assume that we have a 5-year class. The 5-year class, as you know, uses double declining balance or 200% declining balance depreciation with conversion to straight line depreciation. So we assume the basis is 100% and the salvage value is 0, and we also use half year for the first and the last recovery period. So to calculate these rates, right, and these are the rates that we actually see in the modified accelerated cost recovery system, right? To calculate these, we first use the double declining balance. So remember, the double declining balance is just 2 divided by n, but because of the half year assumption, we have 1/2. So this is our 1/2 for the half year assumption, and then 2 divided by n, it's a 5-year class, so n is 5, so 2 divided by 5, the basis is 100%. So when we multiply all of this, right, these 2's are they're gonna cancel off, and if this 5 is at the bottom, so 100 divided by 5 is gonna be 20%. So this 20%. And then we also look at the single line calculation to see maybe single line is faster, which of course it's not, but using single line, that would be again half of the year, and then we have 100% divided by 5 because it's always the same, it's b over n. So this time the n is 5, so 10%. And then here we're choosing the higher one, which is the double declining balance. So the MICRS rate is 20% because this is the highest of the two, the double declining versus a straight line. And then again, calculating the double declining balance is 2/5, right? Because this is a second year, it doesn't have a half year, it's a full year. So 2/5. And then what is left is of the book value, right? We don't have anymore the 100% because this 20% has been subtracted. So the book value at the end of year 1 is 80%. So that's what we're using here is 80%. So 2/5 multiplied by 80% is 32%. So then we look at the single line calculation to see if single line would offer a higher percentage. And so this is our basis. At this time, half of the year already been depreciated, so we only have 4.5 years of useful life left at this time. So we divide by 4.5, so 80 divided by 4.5 is going to be 17.78. Compares it to 32. 32 is higher, so that's the higher rate is what we're going to use for MACRS. So 32 is the rate. And so we subtract the 32 from the 80, right, as this is current book value, or we can add those together and subtract these from the 100. So that would be 52 minus 100, 48, or 32 minus 80, also 48. So that's a current book value at the end of the year 2, and that's what we're going to use in the double declining balance calculation. So using this as a basis, or not basis, book value, and then 2 over 5 for the double declining balance. So we have 19.2%. And then we'll look again using the basis, but now after the 2 years, we only have 3.5 years remaining, because the first year was a half and then another year, so it's 1.5 years that already has passed. So 5 minus 1.5 is 3.5. That's how much is remaining. So we use it in straight line computation. So we divide 48%, which is our basis, in the previous, at the end of the previous year, BV2, we divided by the number of years left of the depreciable life. So it becomes 48 divided by 3.5, which is 13.71. And then comparing it to the rate that's given by a double declining balance, which is 19.2, and this one is a higher one, so we're using this one, 19.2, as an MACRS rate. And so then we subtract it from 48, and that gives us 28.8. Or alternatively, we could have added those together, which would give us a 71.2. And so if we subtract 71.2 from 100, we also would get 28.8. And that's book value at the end of year 3. And that's what we use here in double declining balance and here in straight line. And so again, multiplying for the double declining by 2.5 give us this much. And then dividing by 2.5, which is the remaining years at this point of depreciable life in a single line, it gives 11.52. These actually coincide. So at this time, we choose this 11.52, which happens to coincide here. And then for the year 5, this gives us again 11.52, because this is a year where we switched in year 4 to the straight line. And then the last one is only half, so it's 11.52 divided by 2, so that's 5.76. And so if you look at these rates here, MACRS rates, you can see and go back, right? So you look at these rates here, and you go back to table 11.3 and look at the 5-year class. That's exactly the rates that are in this table. So we can actually get the same exact way. We can get the 3-year class, the 7-year class, the 10-year class. But for 15 and 20 years, we would use, rather than 2 over n, we would use 1.5 over n, because those 15 and 20-year classes, they use 150% declining balance depreciation. All right, so that was an example, 11.5 that we just looked at. So next example is 11.6, and we look at calculation of MACRS-GDS depreciation. So before, that was calculating the percentage rates. Now we actually going to calculate depreciation amounts. So in this case, we don't have to calculate the rates from scratch. We could just use the tables, specifically the table 11.3. So in this example, we have a 7-year property class asset. Its basis is $150,000, and the salvage value is $30,000. And so then again, because it's MACRS, the salvage value is assumed as we calculate depreciation. We assume this 0. And so these are MACRS rates. So you can look at these rates here in this column. Because it's a 7-year property, of course it's going to have 8 years, because the first year is a half year and the last year is a half year. And then if you look at this, notice these are taken from table 11.3. Right, so look at them. Now I'm gonna show you where they're taken from. They're taken from this table. Observe, this is a 7-year property class. This is a table 11.3, and here 14.29, 24.49, and so on. Ending was 4.46. These are the ones, right? These are the rates that we took from this table, and we're gonna use them in our example, right? So these are the rates that we just took from that table. So now multiplying each of these rates by the basis. The basis is 150,000. So you see this is the basis, and then we multiply it by the rate, by the percentage rate, and that if we multiply this by this, that gives us this depreciation amount. If we multiply this by this, that gives us this depreciation amount, and so on. So we start with a book value of 150,000, and then we subtract this to get the new book value. This is a book value at year 1, and then we subtract this from here to get the book value at year 2, and we subtract this from here to get book value at year 3, and then we subtract this from book value at year 3 to get the book value at year 4. Again, subtract the next one, the D5, from book value in year 4 to get the book value in year 5, and so on. So you can see that at the end there we're going to have 0. Book value will be 0 in year 8. So that gives us the book values and the depreciation amounts. Now another example. This is example 11.7. This is a calculation of MACRS-GDS depreciation. We have a 39-year property class. So as you know, that's a non-residential real property. The basis is 2 million. It's purchased in April, right? The months is important because remember, for the real property we're actually using the months. It's not a half-year assumption. We're looking at the months instead. And it's disposed 5 years later in August. So again, what are we gonna do? We're gonna find the MACRS percentages. Where did we find them from? Well, it depends on, right, what we do, right? In this case, it's 39-year property, so that's a table 11.4, and then it's purchased in April, right, and then disposed later in August. So let me show you. So here is the table 11.4. Remember, we are working with a 39-year property. This is a 39-year property table, non-residential real property. Months placed in service is April. This is the 4th month in first year. So it's 1.819, and then it's disposed in August. So we have this 1.89, 1.605, 1.391, 1.177, and this last one is 0.963. Actually, I apologize for leading you on incorrectly. So again, it's placed in August, so we do use 1.819. But these 5, 6, 7, and 8, right, is only if we placed months placed in which we placed it in service. So this 1.819 is used for the rest of the year, and for the next years, it's just 2.564, and because it's 5 years later, this is for years from 2 to 39. So even we dispose it in year 8 in August, it still would be 2.564 all the way for all of those consecutive years. We would have all the way through the 5th year in August, we would still be using 2.56. But during the first year, because it's placed in the months of April, and again these rates are calculated using months assumptions. So this 1.819 is used for the entire rest of the year. So this is during the first year, and this 2.564 is basically used for the years 2, 3, 4, and 5. And so that's what we see here, the MACRS percentage rates, right? We have this one for year 1 and these ones for the consecutive years. And so notice if when we do this MACRS calculations for the first 5 years, right, we are using this 2000 multiplied by the percentage rate, and then for the last year, it was disposed in August. The August is the 8 months, but this is the last months. We're using the half months assumption, so only half of the August can be depreciated. So before that we had 7 months, and the August is the 8th month, so only half of it. So 7.5 months can be depreciated. So this is 7.5 divided by 12, and then that's the percentage of the year that's being depreciated, and then multiplied by the basis, multiplied by the rate for that year. And so multiplying this by this gives us depreciation amount. Multiplying this by this, right, the basis by the rate, gives us the depreciation amount for the second year. This by this gives us the depreciation amount for the third year, and so on. And so here in the last year, because we're only depreciating 7.5 out of 12 months, this is going to be the depreciation amount. So then if we add all of those up, this is how much the total depreciation. So subtracting it from the 2 million gives us this much. So that's the book value at the end when they are selling, when they sold the property. And these are the book values for each of the years, right? So this is at the end of year 1, BV1, this is BV2, this is BV3, this is BV4, and how we got them, we just subtract from a previous book value, we subtract the new depreciation amount. So here subtracting this, we get this. From here subtracting the new depreciation amount, we get this, and so on. So next example is example 11.8, which is comparison of depreciation methods. So if you were to look at this, and this is a this is a book value as a vertical axis, and this is depreciable life in years. You can see that this red line is a straight line method. Then the next one is the sum of the year digits, and then here we could also have the double declining balance. And if you look at the MACRS, you see something like this blue line. So it's depreciated sooner, right? So if it was a normally, it would be a 10-year life, but in terms of MACRS property class, it would fall into 7-year, and so there is a half year right here, and so you would see something like this again, right? It would have been the double declining balance, but it's not the full year, it's only half of a year, so it's smaller than that here, and then goes according to the double declining curve, starting from here, and all the way to the 7, to wherever we have actually to the 4th, where you can see the straight line starts, and this is a half year, so that's not exactly the straight, but half of that angle under which we have the line, right? So this is half angle. So again, you can see this is a modified accelerated cost recovery system. It's probably one of the most advantageous in terms of the tax benefit. And then let's take a look at depreciation and asset disposal. It's important to know that when a depreciable asset is disposed of and the market value is different than the book value, the difference must be treated as either depreciation recapture, which also known as ordinary gains, and that's a depreciation that occurs, or the depreciation recapture, it occurs when an asset is sold for more than the current book value but less than the original cost basis. Or we can treat this as loss, and that happens when an asset is sold for less than its current book value. Or it could be a capital gain, and the capital gain happens when the asset is sold for more than its original cost basis. And the capital gains may be taxed at a lower rate than ordinary gains. So let's take a look at this example, right? So here's our cost basis, which is 10,000. We have about 7,000 of market value, but the book value was 5,000. So between the book value and the market value, right? So the book value is here, the market value is here. We have depreciation recapture of 2,000. In this example, we have cost basis all the way here. The market value happened to be lower than book value. Here we have the loss. This is a 3,000 loss, right? Because this is 2,000, this is 5,000. Here's another example. Notice the market value this time is higher than the cost basis. So in this case, this is a capital gain and the depreciation recapture, right? So this part is a depreciation recapture, and this one is a capital gain, right? The capital gain is the difference between the market value and the cost basis, and then from basis to the book value is a depreciation recapture. So this capital gain might be less, and this is the ordinary gains, and this is the capital gains. Capital gains might be taxed lower than this amount of ordinary gains. So here's an example 11.9, and here we look at depreciation and asset disposal. We have a 3-year property class with the basis being $10,000. So because it's 3-year property class, we're gonna go to table 11.3, and from there we find these rates. This is just taken from table 11.3. Notice it includes 4 years because the first year is a half year and the second year is a half year. So then we have 2 years here, half year here, half year here, altogether 3 years. And then this is an MACRS depreciation. The way it's found is we multiply the percentage by the basis. So basis is 10,000 multiplied by 33%. That gives us 3,333. Then again, multiplying this by the basis, it gives us this much. Multiplying this by the basis, it gives us this much. And finally, multiplying the basis by this rate gives us this much. This is our depreciation amounts. So to find book values, we just subtract each time from the previous book value, we subtract the current depreciation. So from 10,000 of book value at time 0 or basis, we subtract this 3,333 to get this much. This is a new book value, the book value in year 1. From that we subtract this to get this, and then from here we subtract this to get this, and then when we subtract from this the final depreciation amount, we get 0. So then it depends on the market value, right? What is the market value? So we had that asset for 5 years, and during year 5 we sold it at some market value. Assume that market value is 7,000, right? So if it's 7,000 but the book value is 0, then the difference between market value and the book value, which is 7,000, is a recaptured depreciation. If the market value is 0, there is no recaptured depreciation or loss. If the market value is negative 2,000, right, if we need to pay something to dispose of the asset, there is a loss of 2,000. Here's another example, example 11 and 10 also shows us how to apply depreciation in asset disposal. So in this case, we sold the asset during year 2, right? So it's a similar example, but the asset was sold in year 2, also 3-year asset. So these percentages are from the 3-year property class of MACRS table 11.3, and we only include the 2 years out of 4 because it's sold during the 2nd year. So because it's sold, we only can use half year, right? We're using half year assumption. So we multiply this by half year. This is our depreciation amount. And so again, this minus this gonna give us BV1. And then from here we subtract this, and that gives us book value in year 2. But notice book value is $4,444.50, but the market value, we sold this for $2,500. So the market value is lower than the book value. So there is actually a loss, which is a difference between these two. Right? So market minus book value, and that's minus 1944.5, which is a loss. The second example, right, we sold it in year 3, again for $2,500. These are taken from MACRS table for a 3-year class. We're only using 3 rates out of the 4 that are seen in the table 11.3. And then again, right, depreciation amounts are simply this multiplied by 10,000. This is our basis, 10,000. So multiplying this by this, we get this. Multiplying this by 10,000, we get this. And multiplying this by 10,000 and using a half year, right? Because if we sold it here, we only can depreciate half of the year. So this by this is gonna give us this much. So subtracting from 10,000, we get the BV in 1. From here, subtracting 4,445, we get this much. This is book value in year 2. And then from book value of year 2, we subtract depreciation amount in year 3, we get the book value in year 3. And so now the book value at the end there when we sold it is $1,481.05, but we sold it for $2,500. So we subtract from market value, we subtract book value. So from $2,500, we're subtracting $1,481.5, and we get a difference of 1,018, and that's recaptured depreciation or ordinary gains. Here's a third example. Again, we have this book value, but the salvage value is not 2,500. Salvage value is going to be 5,000, and the number of years is 5. So using a straight line depreciation, we would get this much, and that would be our book value, and this is our market value. Right, so if you're looking at the straight line depreciation for this asset during the 5 years, right, so we 10,000 minus 5 is 5,000, divided by 5 is going to be 1,000. And then subtracting this 1,000 happens for every year, right, because it's a straight line depreciation. The depreciation remains constant throughout the years. We sold it in years 3. So we subtract, so here this is not MACRS, this is a straight line depreciation. Subtracting the 1,000, we get 9,000. Subtracting 1,000 from 9, we get 8,000, which is book value in year 2. And then to get the book value in year 3, from book value of year 2, we subtract the depreciation in year 3. So get 7,000, but the market value is 4,000. So from market value, we subtract the book value. So 4 minus 7 is going to be negative 3,000, and that's a loss. Now let's talk about the unit of production depreciation. So there is a different method that could be used, and it's useful when the property, when the recovery of depreciation on an asset is more closely related to the use than the time, right? So rather than so we might have, it depends on how much the asset being used rather than for how long we have used it for. And this depreciation is not considered an acceptable method for general use. But sometimes this unit of production depreciation can be used in books. So the depreciation amount is simply the production in year T divided by the production for all the years from 1 to n, and then multiplied by the difference between the basis and the salvage value. So now, again, this summation, right, is just a summation of different productions from year 1, production amounts from year 1 all the way through year n, which is also known as the total lifetime production for an asset. So now if you look at this, right, we have 5-year depreciable life, the basis is 900 and the estimated salvage value is going to be 70. Then the difference between those is going to be B minus S is going to be 830. And we want to know annual production to use unit of production depreciation. So during the first year it's 4,000, during the second year is 8, during the third year is 16, during the fourth is 8, during the fifth is 4 units. So then we can use the unit of production calculation. So this 4,000 is going to be divided by the total, right? So the total is computed by adding all of those up. We sum 4,000 during first, 8,000 during second, 16 during third, 8 during fourth, and 4 during fifth. So you get here, for example, 4 and 8 is 12, 12 plus 16 is 38, and 38 plus 8 is going to be, sorry, not 38, 12 and 16 is going to be 28, 28 and 8 is going to be 36, and then 36 plus 4 is going to be 40,000. So this 40,000 is a total production during the lifetime. So we're going to divide this 4,000 by 40,000, and then multiply by 830. So it's the same as 830 divided by 10, which is 83. And then the same here, 8,000 divided by total production, 40,000 multiplying by the basis minus the salvage, which is 830. And so that gives us 166, and so on. So these are depreciation amounts, so we're subtracting those from the basis. So book value in year 0 at the beginning is the same as basis, 900, and then we're subtracting 83, that becomes book value at the end of year 1 will be 817. Then from this BV1 we subtract the depreciation in year 2, and it gives us BV2, and so on. From this, subtracting depreciation, we get the new book value. From the old book value, subtracting depreciation, we get the new book value. From the old book value, subtract this new depreciation, get the new book value. And so you can see that from 9 to the salvage value of 70. Now, related to the unit of production depreciation is depletion. And depletion is exhaustion of natural resource as the result of the removal of that resource. And it's used except for standing timber and most of oil and gas wells. We have depletion allowance, and that's the larger of the methods. The two methods, either cost depletion or percentage depletion. So the cost depletion is very similar to the unit of production depreciation method. It's permissible for standing timber and most oil and gas wells, and the cost of land must be excluded from the property cost. And the second method is percentage depletion. So keep in mind, right, so except for timber and most oil and gas wells, we use the largest depletion allowed by either cost depletion or percentage depletion. So percentage depletion is a depletion allowance is a certain percentage of property gross income during the year, and it cannot exceed 50% of property's taxable income computed without depletion deduction. So here is an example that shows a table which gives the percentage depletion allowances for different types of deposits. Example, right, this is natural resources that are listed, sulfur or uranium, and so on, right? We have rate of 22%. for example, for gold, silver, copper, we have 15%. For borax, granite, limestone, marble, we have 14%. For coal, lignite, sodium chloride, we have 10%. For clay, we have 7.5%. And then for clay used or sold for making drainage or roofing tile, we have 5%. So you can see this percentage depletion allowances. This is a table you use to find the percentage depletion. So now first let's take a look at cost depletion method. We have the cost of property, which is a timber, and we have $35,000 as a cost of property. We have cost of land, which was $5,000. It's included in the cost of property. So remember, we can use the land, depreciate the land, because it has indefinite life. So we have to subtract this 5,000 from 35, so it only gives us 30,000. And an estimated timber production is 1.5 million board feet. First year production is at 100,000 feet, right? So this total production is 1.5 million. So we're going to divide this 100,000 by 1.5 million. And that's what we do, 100 divided by 1.5 million. And then from, like I said, from 35, which is the total property cost, we exclude the cost of the land, because the land is has indefinite life. So that's a 30,000, and so multiply by this, it gives us 2,000. So that's a depreciation amount using the cost depletion method for using this percentage for year one. Now let's take a look at percentage depletion. The gross income is $250,000, and the mining expenses are $210,000. So the percentage depletion is going to be 10% multiplied by the gross income, so it would be 25,000. The taxable income, right, is going to be 25, which is the income minus the expenses. Income minus expenses is going to be 40,000, and there's a taxable income limitation, so only 50% can be used for depletion purposes. So 40, which is our taxable income, 40,000, multiplied by 50% is only 20,000. So 20,000 is less than this percentage depletion. So we can't deplete more than 20,000, and this is more, so we only deplete 20,000. So last but not least, let's take a look at the spreadsheet functions that can be used to compute depreciation. Specifically, Excel has this function SLN, and that is used for computing the straight line depreciation. The first parameter is the cost, and the second is salvage value, and this is the life, right? So this is the basis, this is the salvage value estimated, and this is a depreciable life. And then we have in Excel also double declining balance, DDB function, and that computes depreciation using the double declining balance method. Again, cost, right? This is the basis. This is the estimated salvage. We have depreciable life, and then we need the period, right? Because the SLN, it's constant for each period. Double declining balance depends on the period, and then we can also have this factor, and again, factor is not required. This parameter is not required. Also, the sum of year digits has a function in Excel, SYD. Again, cost, salvage life, and the period, like before. And then last but not least, there is also this variable declining balance, and there you can specify a specific parameters, right? Not just cost, salvage, and life, but you can also have the start period, the end period. You can have a factor, and then switch or no switch. So this returns depreciation of an asset for any period specified, including partial periods, using the double declining balance method or some other method specified. and VDB stands for variable declining balance. Alright, so that's it for today. I hope that you learned a lot from this topic, and later this chapter 11 information about depreciation and depletion will be used in when we talk about taxes in chapter 12.